Hey guys, and welcome back for another lesson on inequalities, solving linear inequalities this time. Now, if you weren't here for our introductory lesson to inequalities and number lines, I'm linking it down for you in the description down below. If you're new to Team Danielson, let me just explain to you how this is going to work. First, I'll take you through a lesson, including a couple of examples, and then I'll leave you with a pause and practice exercise with the answers taken up at the end. If you want to skip ahead to that, again, look down below and I'll show you what minute you can jump to. But if you haven't been through this theory yet, definitely take the time to go through it and make sure that when you're doing your answers, you're solving your questions the same way to make sure you'll get full marks. Let's get started. First of all, before you can solve an inequality, I hope you can already solve an equation. When we solve equations, we just need to rearrange the equation to get the variable, that's our letter term, by itself. So for example, here is an equation. We've got 2 that's being multiplied by the x, and the 3 is being added on, and the final answer is 7. If I want to know what x is, I need to get it on its own by undoing those operations that are acting on it. First, I'll get rid of the 3. It was adding, so I will subtract. Then I'll get rid of the 2. It's multiplying, so I'll divide. And then I've got my x on its own, and it's simply 2. My answer is 2. When we solve equations, we get a final answer as the value for the variable. But when we solve inequalities, we get a range of possible values for the variable. Let me show you an inequality. So it looks very, very similar, except for instead of an equal sign here, it kind of looks like the equal sign has been pinched down to be smaller on one side. That means that the 7 is smaller than 2x plus 3. They are not equal. I'll rearrange this in the same way though. So I want to get the x on its own. X is being multiplied by 2, and then 3 is added. So I'll get rid of the 3 by doing the opposite. I'll subtract the 3 to the other side. And then I'll get rid of the 2. The 2 is multiplying, so I will divide the 2 on the other side. And x is greater than 2. Again, this symbol looks like an equal sign, but it's been pinched down, so it's smaller on the 2 side, which means it's bigger on the x side. X is bigger than 2. Now be very careful. This is not an equation, so don't ever say your answer is simply 2. That is not x's value. In fact, in this case, x cannot even be 2. X is greater than 2. So x could be 3 or 4 or 2.00001 or 552. It could be any value greater than 2, not including 2. It'd be easier for me to show you on a number line. On my number line, here I've started with 1, but you don't need to. You need to show the boundary value. We've just worked out that x is greater than 2. So I'll circle that boundary value, but I will not color it in because x cannot be equal to 2. X is only bigger than 2. So an open circle on 2 and an arrow showing all of the values greater than 2. Those are all of the possible values for x. Let's see another example. Now this time we've got a two-sided inequality because I've got a variable on either side of the inequality symbol. Now it's got to be the same letter or we can't solve it. But since they are the same letter, I can get those letters together on the same side of the inequality and send all the numbers to the opposite side of the inequality to then solve like I just have. Now if this were an equation, it would not matter which side you put the x's on. However, I generally tell my students to try and keep your variables positive. So the general rule to follow is to always move the smaller variable term. So in this case, this is 1x and this is minus 1x. Minus 1 is smaller than 1, so I'm going to take the negative x from this side over to that side. This x is being subtracted over here, so I'll take it over there and I'll add it. In that same move, because I knew I was going to group my x's over onto this side, I started moving the numbers over to the right-hand side as well. The 9 was already there, so the 9 stays there first, and the order is important here. And the 3, which was added after this x, was subtracted over to the other side. So now here I've got an x plus another x, which is on the pinched down side. That's the smaller side of this inequality, which is underlined, so that means that it's less than or equal to 9 minus 3. Now just simplifying it, Because x is the same letter as x, we can group those together. They are like terms, and I can say that those are 2x's. So 2x's are less than, my answer of 9 minus 3 is 6. Working vertically downwards with my inequalities nicely lined up so I can see where all of my answers are coming from, and I can follow along with the working. Now I want the x completely on its own, so I need to get rid of the 2 that's in front of it. That 2 is multiplying by x. So we need to take the 2 to the other side and divide. So starting with the 6 there first, it's 6 divided by 2, not 2 divided by 6. You see how the order is very important. So x must then be less than or equal to 3. Again, that symbol is pinched down on the smaller side, which is pointing to the x. X is less than 3. But because it's underlined, x is not just less than 3, it's less than or equal to 3. It might be easiest for me to demonstrate this for you on a number line. First, I will identify the critical value or the boundary value, which is 3. And I'm putting a circle around 3, but I am coloring that circle in because I'm showing that x could also be 3. If this is underlined, we color in the boundary value. And x is less than or equal to 3, so my arrow is going to go in the downwards direction from 3. So the value is smaller than 3. X could be any value less than or equal to 3. So x could be 3, 2, 1, and so on. Alternately, we could have solved this inequality a slightly more difficult way. Remember I said always move the smaller x term to keep things positive? Well, if you didn't listen to me then, you might get yourself in a bit of a mess, but let me show you how to get your way out of it. If I started by moving this positive x over to that side, I would end up with minus x minus another x, and things are getting negative. In the same move, because I realized I was going to move all my x's over to the right-hand side this time, I took my 9 over to the left-hand side. The 9 was positive. That minus belongs to the term that follows. That belonged to the x. So that positive 9 went to the other side after the 3. The 3 was here first, and the 9 was subtracted off from that. The order is important. The 3's first, the 9 comes after, so we write 3 minus 9, not 9 minus 3. And on the right-hand side, you can see how messy this is going to get because I've got negative x minus another x. That's minus 1 minus another 1. That's going to be minus 2x. So I'm going to end up here with a negative 6 on this side. 3 minus 9 is negative 6. And minus 2x on the other side. Now I know what you're thinking. We'll just do like we did before. Take that negative 2, which is multiplying to the x, over to the other side and divide by it. But there is a special exception. There's a special rule we need to follow. When we move a negative term to the other side and either multiply or divide by it, that's when we need to change the direction of the inequality sign. So I had a less than or equal to sign before. It used to be the negative 6 that was on the smaller side. But when I changed this side of the inequality from negative to positive, and I changed this side of the inequality from negative 6 to positive 3, because negative 6 divided by negative 2 becomes positive, that's where I have to change the direction of the inequality sign. I know this is a confusing rule to understand, and I'll explain it a little bit better in a minute, but let me just take a moment to pause and remind you there's a way to avoid this. Always try to keep things positive if you can. Move the smaller variable term to avoid having negative variable terms. Right, let's explain that now. So the plus minus and inequality direction exception even has a fun sort of name to it. Let's hope we can clarify this. First of all, as I've been trying to say, try to keep your variable positive. But if you can't, remember the rule. First of all, I've got this inequality here, and it seems pretty simple. Negative x is greater than negative 2. There's not much for me to do to try and solve it. I just need that negative x to be positive, so I need to change the plus or minus sign. Now that's where our exception comes in. As you can see, I've drawn a number line here where negative x is greater than negative 2. Not coloring in the negative 2 because it's not underlined, and showing that negative x is on the upper side of that. Now this number line is not the solution to the inequality because I haven't fully simplified it yet. I need the inequality to be solved where x is on its own. But so far I can show you that negative x is greater than negative 2 means that negative x is less negative than negative 2. I don't want anyone getting confused and thinking greater than negative 2 means negative 3, negative 4, negative 5. That's less than negative 2. So this is greater than negative 2. Well, if that's the case, negative x could have these values. It couldn't be negative 2 because it's not colored in, but it could be negative 1, 0, 1, 2, 3, and so on. All of these values are less negative than negative 2. That is, they're greater than negative 2. If we just change the sign on both sides, look what I end up with. If I just say that x is greater than 2 on my number line, it looks like this. 2 is my boundary value. I didn't color it in because it's not underlined. And I've showed that x is on the upper side of it. X has got values higher than 2. But look at the set of possible values for negative x. If I just change the signs on both sides, I didn't expect positive x to be 2, 3, 4, 5, 6. Those sets of values don't look similar at all. I'd expected to just change the sign here and just change the signs here, which this has not done. However, if you follow the rule, which is when we change the plus or minus signs in an inequality, we have to change the direction of the inequality symbol. My arrow will go in the opposite direction, and you will see that x being less than positive 2 gives me values of x being 1, 0, negative 1, negative 2, negative 3, and so on. They're the same values as we have above, except we are just changing the positive or negative sign. So hopefully I've just proven to you that just changing the positive negative signs will not solve your inequality. You need to change the direction of the inequality sign anytime you go from negative x to positive x or positive x to negative x. Now I hope that was made clear, but again, try to avoid this situation. If at all possible, try to keep the variables positive. So here's another example. And again, I want to try to keep my variables positive. So will I move my negative 2x to the right side, or will I move my negative x to the left side? Which one is the smaller variable term? Negative 2x is more negative than negative x. So that is the smaller x term. That's the term we should move. So I'm moving my negative 2x from the left side to the right side. And at the same time, I'll move my 9 from the right side to the left side. Right? My negative 2x was minus. When I take it over to the right-hand side, it becomes plus. My 9 was positive. When I take it to the left side, it becomes minus. So 7 minus 9, which is negative 2, is on the smaller side of this symbol, so is less than or equal to, because it's underlined, negative x plus 2, which will give me positive x. So I've got my inequality solved there. X is on its own, x is positive, and x is on the bigger side of this inequality sign. X is greater than or equal to negative 2. Now I can show you that again on a number line. Again, I'll show you clearly what the critical value is, that is the boundary value, negative 2. This time I'm putting a circle on negative 2 and I'm coloring it in to show that negative 2 is a possible value. X is not just greater than negative 2, x is greater than or equal to. If it's underlined, it's colored in. To show the value is greater than negative 2, I'll draw my arrow in the right-hand direction because these are the values that get higher as we go along. These are all of the values higher than or equal to negative 2. X is greater than or equal to negative 2. That means that if x is an integer, An integer means a whole number. X could have the values -2, -1, 0, and so on. Now, I did that the easy way, but if you forgot or made a mistake or somehow got muddled up and didn't realize that -2x is smaller than -x, we can do this the hard way as well. So alternately, let's show you that trick again when we end up with negative variable terms. So if I made the mistake of saying I'm going to move this -x over to that side because that's going to make that positive x, but I'll have -2x plus x, it's not going to make things positive. -2x plus x is just going to become -1x. And minus x being less than or equal to 2 is not the solution to this inequality. I need the solution to be just x on its own, no minus sign out front. So I need to make this -x positive. If I change the sign of this side, I need to change the sign of the other side. So -x is less than or equal to 2, positive x, and again I change the inequality sign as well, is greater than or equal to -2. I've changed the plus or minus sign on both sides of the inequality, so I changed the direction of the inequality as well. And as you can see, these answers are now the same. The x is on the bigger side of the inequality sign, and the -2 is on the smaller side of the inequality sign in both cases. So you see, it is necessary to change the direction of that inequality sign, unless you remember to keep things positive. Now, reminders before I get you some practice. First of all, when solving an inequality, do not give a number answer. It's the best way to lose marks on an exam. You solved an inequality, you've got x is greater than or equal to 2, and you write your answer 2. That will get you a 0 on an exam. Be careful. Next, an underlined inequality sign means to include the boundary values. So if you've got a greater than sign with a line underneath it, means greater than or equal to. For underlined inequalities, circles are colored in on the number line. If you're drawing a number line to go along with your inequality, make sure that underlined inequalities have colored in circles. Not underlined inequalities have open circles, not colored in. To solve inequalities, we solve them the same way as we solve normal equations, with a couple of exceptions, remember. The big exception is when we multiply or divide both sides of the inequality by a negative value, the direction of the inequality sign changes. So if it was a less than sign in between the values, we turn it around and it becomes a greater than sign, and vice versa. Okay, let's get some practice. The first row of this practice is just one-sided inequality. See, we have the variable just on one side of the inequality sign. However, do be careful when your variable is negative. One possible way to fix this is just to move the b across first thing. That would make my negative b a plus b on the other side, and everything goes a lot easier from there. A little bit more difficult with this one. The second and third row, they're all two-sided inequalities. We've got the letter on both sides of the inequality. But so long as they're the same letter, we can still group them together and then send the numbers to the opposite side and solve. Again, remember to move the smaller variable term to try to keep things positive. Now go ahead and hit pause now, and the answers will come up in just a minute. I hope you've had a chance to hit pause. Here come your answers. For the first line, now if you had written here a is greater than 4 or 4 is less than a, that's fine. It doesn't matter which side you put the 4 or the a on, so long as a is on the bigger side and the 4 is on the pinched down smaller side. Same thing with b and c. B is on the smaller side of this symbol, C is on the bigger side of this symbol. Next line. And last line. Now let's try expressing these answers on number lines. So for question A, I want to see this answer on a number line. Your critical value is 4, and I want you to show me which direction is A from our critical value. Is it greater than or less than? For B, our critical value is negative 25. Your number line doesn't have to start at 0. Start at any value you like. And I want you to tell me if B is greater than or less than negative 25. Notice this is underlined. Remember what that means for your number line. Go ahead and hit pause so you can set up your number lines. Answers are coming up in just a moment. I hope you've had a chance to hit pause. It takes a while to set these number lines up nice and neatly. Let's go ahead on to the answers. A is greater than 4. So my critical value is 4, and I've got my arrow shooting up from there. For B is less than or equal to negative 25. So I've colored in my circle on our critical value negative 25, and I've shown my arrow going to the more negative values, the lower values on the left side. Next, C is greater than or equal to negative 3. Now I've made a mistake on my answer here. What mistake have I made? That's right. It's an underlined inequality. C is greater than or equal to negative 3. So my point needs to be filled in to show that negative 3 is included in the possible values for C. Question D. D is less than or equal to 3.5. E is less than negative 6. F is greater than or equal to negative 7, so I've colored in the circle that time. G is greater than negative 4. H is greater than or equal to negative 1. Again, I color in that circle. And G is greater than or equal to negative 1.75. Coloring in that circle again. And I hope that you found this lesson and practice helpful. Please comment if you think I could clarify anything for you. And like and subscribe if you want to see our next video on solving composite inequalities. Until next time, keep practicing and I'll see you soon.